let's study about ionization potential or ionization energy. And you know this, that this is a periodic properties of an elements, and it is directly related with the atomic radii or atomic radius. Now this is, if this word seems hard to you, that is my request to please watch this video and then do let me know that you understand really after watching these videos that what is ionization energy. So understanding this, we need to think one thing, that the energy required to transform one positive ion from an element removing one electron. Why we need to think about it? Suppose, which is very common that I'm explaining since first class, that number 3 period, think about it. Suppose sodium, So in case of sodium, the electron configuration is 1s2, 2s2, 2p6 and 3s1. Okay? And then what about chlorine? That is 1s2, 2s2, 2p6, 3s2, 3p5. Okay? So it means that it has total 3 shells, sodium, and chlorine has also 3 shells. But the difference is the atomic number of sodium is 11 and chlorine is 17. Now why the ionization energy will vary, and what is ionization energy? I'm coming up with the definition, but before that I'm giving you the idea how to think about ionization energy. Now you think this is sodium, and suppose this is the nucleus, and this is the first shell, this is the second shell, and this is the third shell. Similarly, in chlorine, this is the nucleus, first shell, second shell, and this is the third shell. The thing is, in second shell there are, first shell 2 electrons, second shells 8 electrons, and in the third shell, KLM, in the M shell of sodium, it has only 1 electron. But in chlorine, it has 2 electrons, 8 electrons, and in the outermost shell it has 7 electrons. So here is 2 electrons in first shell, 8 electrons in the second shell, and 7 electrons in the third shell, whereas there is only 1 shell in 1 electron in the M shell of sodium. So it means, here comes the difference. The difference is, so if sodium wants to donate, even not ever donate, removing of electron, if I want to remove this electron, 1 electron from 1 sodium atom and 1 electron from 1 chlorine atom, do you think the required energy will be same? No. Why? Because if you want to remove this electron, it is much easier than chlorine, because chlorine has 7 electrons in its outermost shell, so it has much affinity, it has attraction to the nucleus. So from that attraction, if you want to release 1 electron, or if you want to remove 1 electron, then the required energy in case of chlorine comparatively to sodium will be much higher. That means the definition is the energy required to transform 1 positive ion or 1 mole positive ion removing 1 mole electrons from 1 mole atom in its gaseous state is called the ionization energy of that element. I'm repeating it. Do you understand? The definition of ionization energy is the energy required the energy required to transform one molecule or 1 mole of positive ion, removing 1 mole of electron from 1 mole of atom, 1 mole of atom in its gaseous state. Like that. What is the thing? Suppose sodium is releasing 1 electrons. So if sodium is becoming sodium plus by releasing 1 electron. Chlorine, if chlorine becomes like that, releasing 1 electron, do you think, we always see that chlorine is a minus or in its negative ion, but now we are seeing that 1 electron was released or removed from the chlorine atom and it becomes positive ion. That means if this sodium is 1 mole and this sodium ion is 1 mole and this electron is 1 mole, then the energy required, that is actually in case of sodium, is 496 kilojoule per mole, and in case of chlorine it is 1251 kilojoule per mole, if I am not wrong. See the differences. There is 496 kilojoule per mole in case of sodium first ionization energy, but in case of chlorine the first ionization energy is 1251, which is almost 3 times greater than sodium. Why? Because removing 1 electron from sodium atom actually, removing this one, this is very easy because there is only 1 electron. So sodium is naturally prone to donate electron. So the required energy to remove some electrons from sodium is very easy. Whereas chlorine wants electron to get settled. That is why the law of octet will be fulfilled. Here electrons, I am removing electrons from chlorine. So that definitely the required energy will be high in case of chlorine, and that is why this is ionization energy. So what is the explanation is that? The explanation is that the chlorine, chlorine is becoming chlorine positive ion by releasing 1 electron. You can say this should be like that, chlorine releasing 1 electron and become chlorine ions positive. That is okay, but we usually write these electrons on the right side as a becoming sign plus, so the same thing. So what is the definition of ionization energy? This is 1 mole and this is 1 mole, so this is 1 mole. And of course this should be gaseous state. So the definition of ionization energy is the energy required to transform 1 mole of positive ion, removing 1 mole electron from 1 mole atom in gaseous state of that element, is the ionization energy of that element. So we can say that ionization energy as IE. So if you see that, if I say like, okay, sodium and sodium, magnesium, suppose there is sodium, we can say that sodium, magnesium, aluminium. So the ionization energy is 496, in case of magnesium 738, in case of aluminium is 578, in case of silicon this is 776. Silicon, that is phosphorus, in case of phosphorus is 1012, in case of chlorine is 1251, and in case of argon this is 1521. So all these ionization energy is kilojoule per mole, and this is actually the ionization energy 1. and if you remove more electron, then the ionization energy will be 2, and then ionization energy will be 3. And it also varies. How? Let's see. So if you think about more about sodium ionization energy, sodium ionization second energy, then it is 4560 actually. Suppose ionization energy 1 of sodium and ionization energy 2 of sodium is 4560, and this is 496. Now I just want to give you something deeper. Why the sodium first ionization energy is so less than the second ionization energy? Now you think that why it becomes like that. Suppose in case of ionization energy 1, sodium is just, we need to remove 1 electron from 1 sodium and it will become sodium plus. The required energy is comparatively very less, 496. When it becomes sodium plus, that means it has only 10 electrons. That means in sodium atom, first shell and now only the second shell. So here 2 electrons and here 8 electrons. Now you think that after ionization energy 1, that means you already removed the last electron from the third shell, and after you removing of 1 electron, after losing 496 kilojoule per mole energy, you have become like sodium is getting this shape. That means only 10 electrons are there. Now ionization energy 2 means, now if you want to remove another electron from this state where sodium gets the stability, like it becomes like neon. Now the sodium, while it has 10 electrons, it's become more stable, and from that stable state, if you want to release 1 again electron, then you require more energy. And that is why this is at least 9 times greater than this, almost 9.5 times more energy required in case of ionization energy 2. So if you want to release this, again you want to release another electron, then it will become ionization energy 3. And if you see the ionization energy of periods 3, this is the amount. And you see that why it's becoming so, why it's so variable. You see why variable? This is 496 because the outermost shell has 1 electron. It is 738. It's getting more because the ionization energy of magnesium is higher than sodium, and this is directly related with the atomic radii. Why? See, in case of atomic radii or atomic radius, if you go from left to right, atomic radius decrease. That means the atomic radius decrease means size of the atom decreasing when I go from left to right. But if I go from upwards to downwards, then the atomic radius will increase. And this is completely vice versa with the ionization energy. So the ionization energy is completely the vice versa with the atomic radius. So if you go from left to right, then the ionization energy will increase, and if you go from upwards to downwards, ionization energy will decrease. Why? Because the more atomic radius, the less ionization energy. So if you go left, if you go right, the ionization, the atomic radius decreasing, so ionization energy will increase. So if you see the ionization energy, so it's something like that. So usually the ionization energy of silicon is 776, which, and sodium is 497. So if you go right, then the atomic radius will be increased and the ionization energy will be decreased. And if you go in a group from upwards to downwards, the atomic radius will increase but the ionization energy will decrease. So this is a complete vice versa relation with atomic radius and ionization energy, and this is also same for the electronegativity and electron affinity. That is completely vice versa with the atomic radius. And I'm coming with the next video regarding electronegativity and electron affinity. And I hope I can make you understand that what is the definition of ionization energy, what is ionization energy 1, 2, 3, and why it varies, and what is the ionization energy of period number 3. And you must remember one thing, that if you go from left to right, ionization energy will increase. If you go from upwards to downwards, ionization energy will decrease. So I hope you understand and you can remember, and I hope you will study better, so that whenever you see anything, because chemistry is a lovely subject, if you can read it from your heart and using your brains, then you can see the beauty of chemistry. And I'm requesting each and everyone to please concentrate on your study from your best level heart, so that you can understand things with fun and joy. So it's not about pressure. Though I think the students of English versions or even O-level, if you feel like that's ionization energy, what, some sort of toughness? No. Right now you understand? And in the first time of videos that I already said that if after watching this video, if you feel that you didn't understand ionization energy, do write me in the comment section of these videos. I will definitely answer. So I'm waiting for your feedback. Take care. See you on the next class with the electronegativity and electron affinity. Take care.